So this has to do with the quadratic equation, and to understand what the quadratic equation is used for, it's best just a very basic idea. Most quadratics or parabolas cross, I shouldn't say most. Yeah, that'll do. Let's say -1. Cross the x-axis. And when it's easy to figure out the number, when the number's a whole number, we can just use factoring. When it crosses the quadratic, or sorry, when it crosses the x-axis, when it has two x-intercepts like this, that are clearly decimals and difficult, we generally have to use the quadratic equation. I'm going to keep that formula around. This one clearly crosses the x-axis twice, but if it was facing upside down, it clearly crosses none times, 0 times. And then in some situations, a quadratic will cross 1 time. Oh, let's see, divide, no, let's try minus, plus, yeah, minus 0.75. And when it crosses once, its vertex is clearly on the x-axis. And despite our intuition, which says, well, that has one root, it only crosses once, in reality, it has two real roots, or two, how do they phrase it? They phrase it as two equal real roots. And that's because in that case, if I'm going to give you another example, as soon as I stop glitching around here, when I have something that has the same factors, x minus 3, x minus 3, that has two equal roots. Right? I'm going to turn off the other one. Two equal roots, but crosses the x-axis at this one point, and that's because the roots are the same. When we solve for that at 0, when this is equal to 0, well, x minus 3, for it to equal 0, x must be 3. And in the case, since they're both the same, the solution of x equaling 3, that's the only way this bracket can become 0, is clearly happens twice, which is why it has only one x-intercept, but two roots that are equal. These are called two real equal roots. So in any other situation, though, it either crosses twice, as is in the case here, or not at all, as in the case here. Twice, not at all, or once. And that's twice is called, well, I'll go back to this one. Twice in this case is called two unique real roots, or two different real roots. And no real roots is when it doesn't cross at all. Well, when we have an equation, instead that can't be factored, in this case, this one could be factored, but we'll just pretend it can't be and say it's +2, maybe. Yeah. We would instead use the quadratic equation. And the quadratic equation says we use a, b, c. And I know it's long, but this is all important anyway. You're going to be using it again, trust me. That number in front here is a, not 3x squared, just the -3. This number here is called b, not 3x, just the 3. So a is -3. And this number here is called the c. In this case, it's 2. So we would use the quadratic equation. The quadratic equation is minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, it might look confusing, but in reality, that's exactly how we solve for it when we solve from a completed square perspective. And I'm just going to put it in its proper way. B squared would be like that. And square root would be like that. And this plus minus simply means we do it once, that's plus. and once with a minus. And we would just plug in our numbers. But this is what we're studying right here, this discriminant. When this discriminant, it's called a discriminant, this formula right in here. Now I'm getting to the question. When this discriminant is equal to 0, it means there's only one across the x-axis once, or as your teacher calls it, two roots that are equal. But it just crosses once. When the discriminant is positive, in other words, when the discriminant, I don't know why, there we go, it comes out as a positive number, it has two real roots that are different. They cross the x-axis twice in two different spots. And when the discriminant is negative, it means that the parabola never crosses the x-axis. Now, there's another way of saying this. Equals 0 is fine. Equals positive, the way you can say that is bigger than 0. Any number bigger than 0 is by definition positive. And of course, any number smaller than 0 is by definition negative. And this brings us to the questions here that you have. For this, if this had a normal number here, and in this case, k just stands for a number that we don't know yet. For this to have one root, well, the quadratic equation, b squared, in the discriminant only, that's what we're going to focus on. For it to have two roots that are equal, this here, not this here, would have to equal 0. And so we just simply fill it in. So let's talk about the two roots that are equal. That means when it touches the x-axis only once. Well, let's identify our a, our b, and our c. C is easier. C is minus 3. That's our c. B is easy too. It's 2. But this k is confusing. It's just a number we don't know yet. And so this, our a is k. Our b is 2. And our c is minus 3. K just represents a number we don't know yet. Sometimes your teacher's tricky and he puts 4k here, in which case a would be 4k. Right? Whatever the number is here, not counting the x squared, that's a. Sometimes the teacher puts k here, and therefore b would become k, and a would give you a number here like 4. But in this case, let's work with what we have. A is k, b is 2, c is minus 3. So for us to have two roots that are the same, this whole thing would have to equal 0. So we just substitute in, well, our b is 2, so b squared, 2 squared, what's 2 squared? 4. Minus 4 times, I'm going to skip a for now, times c. Our c is minus 3, so it doesn't matter when you multiply these things, they're all multiplied. But minus 4 times minus 3 is plus 12. And finally, what's our a? Our a is simply a number we don't know called k. Well, now that we're only missing one thing, the k, and this has to equal 0, we can solve it. First, we have to subtract 4 from both sides. So 12k is equal to minus 4. Then we have to divide by 12. K is equal to minus 4 over 12. Then we have to simplify. This can be divided by 4, and this can be divided by 4. And when we do that, we get minus 1 over 3. Therefore, the number in front of x squared here, for us to have two roots that are equal, that's when this discriminant is equal to 0, must be minus 1/3. That means that that's true. This will be minus 1/3 when our quadratic only has one touch on the x-axis. Let's see if that's true. It's always good. And I know you don't want to spend a lot of time, but when you don't spend a lot of time, people fail. So when this is minus 1/3, and I believe this was 2, and this was minus 3, Sure enough, there we go. It has one x-intercept. The next question is, well, when does it have two x-intercepts? Well, clearly, when this number changes, it might. And it clearly could have two x-intercepts, and it clearly could have no x-intercept when this number changes. But what we're going to be focusing on is when this number changes. So far, this number here is minus a third when we have 1. It wants to know, well, what is k when the discriminant, we'll go back to k here. What is the number in front here when the discriminant has two roots that are unique, different real roots, it's called? Well, in that case, the parabola in question would cross the x-axis twice. We know k is negative a quarter when it crosses once. The question is, what is it when it crosses twice? Well, we got to go back to the discriminant again, b squared minus 4ac. And when we have two real roots, it's equal to a positive number. Well, a positive number, another way of saying that, is bigger than 0. I don't know why this is bigger than 0. So when is b squared minus 4ac bigger than 0? Well, we fill out the information we have again. B is still 2. C is still minus 3. So you get to the same thing again. You get 4 plus 12, because minus 4 times minus 3 is plus 12. K. This time we just answer, when is it bigger than 0? Well, it's the same formula. 12k bigger than minus 4, and then we divide by 12. So it's when k is bigger than minus 4 over 12, which is minus 1 over 3. So what's a number that's bigger than minus 1 over 3? Well, minus 1 over 2.9 technically is more positive than minus 3. Keep in mind that bigger than minus 3 on the number line, when this is negative a third, it's any number to the right of negative a third, any number that's more positive than negative a third. Well, there's billions of numbers bigger than that. So we discover, well, let's say minus half. Actually, minus a half is not bigger, it's smaller. But let's go with just minus a quarter. There we go. That's got two big real roots. And I said minus 1 over, I had to go the other way, 3.1. There, that's more positive than negative a third. Even 0.1 has two real roots. Harder to see until we zoom in. So it's clear that any fraction that's slightly bigger than a third will work. You know, even 3.001. Can't see it, but it's there. So you can see that any number, therefore, when this a is bigger than negative, bigger not equal, negative a third, this is true. So we're going to add the slider a, and we're going to say, we're going to look at the quadratic, and we can see that when it's 0.5, what's negative a third? Negative 0.33. Right? Oh, negative. Oh, I made it negative. I didn't have to, because I've already made the negative down here. So we can see there it is. So as soon as I make it bigger, my quadratic, not a very good one. I have to make my steps a little smaller. So from negative 2 to 2. There we go. You can see as soon as it's more than a third, it gets to x-intercepts. And also that's because the a becomes positive in front and faces upwards. Right? So really it's anything bigger than negative third. So I can make the top end, 2,000. There, it'll go on forever to it's 22,000. And only when it hits negative a third here, negative 1/3, does it face down. Oh, sorry, I'm going to sneeze. And you can see when it's smaller than a negative third, it always stays below the x-axis. So there's a clue Right there, we know the solution to the other thing. When will it have no real roots? When k is smaller than a negative third. Yeah. That means when we do these questions, we really only have to find two of them. When is the discriminant equal to 0? That'll tell us that k in this case is equal to negative a third. When is the discriminant bigger than 0? In this case, we discovered it's when k is bigger than negative a third. And therefore, when there's no real roots, i.e. when it's a negative, when the discriminant is negative, another way of saying that is smaller than 0, k is smaller than a negative a third. So really, it's just finding this one, and then this one automatically is the opposite direction. I do want to give you a word of warning about solving something. When you have a negative number multiplying k, let's say plus 3, and we're solving it for equal to 0, and so therefore when we're solving it for bigger than 0, and therefore negative 3k is equal to negative or bigger than negative 3. When you divide by a negative number here to solve the last one, the rule about dividing by a negative number is the sign must change direction. K smaller than 1. So this is important. I bring it up because k doesn't have a negative multiplier here. But when you do divide, when you're solving these inequalities, and you divide by a negative number, the sign, whatever way it was facing, must switch. Okay, keep that in mind. We'll just do the second one so that we have a good example. I imagine the second one has a negative multiplier. That's what he's trying to teach you. But it's the same thing. So the question is, when does it have two equal roots? When it touches the x-axis once. That's when it touches the x-axis once. Two different roots is when it touches the x-axis twice. No real roots is when the parabola is below or above the x-axis. So we'll solve it. Notice in this one, the k has changed positions. In this case, the k is in the B format. And you might say, well, A doesn't exist, but yeah, there's always an invisible 1 here. So A is 1. B in this case is whatever's in front of the x, k. And our C is 4. Now, please note, sometimes the teachers make it a number. And also, please remember that dividing rule I just said. Very important. So in this case, our discriminant, b squared minus 4ac, the simplest one to solve, is when it's two roots that are equal. When does it touch the x-axis? Once. It's when it equals 0. Our b is k. So here's where we're going to have an interesting situation here because we have to take a square root. K squared. Our minus 4, our a is 1, so minus 4 times 1 is 1. And our c is 4, so minus 4 times 4 is negative 16, is equal to 0. So it becomes k squared is equal to 16. And here's the unique one. K squared, when we take a square root, we have to say, well, the answer is when k is positive 4 or when k is negative 4. So this is interesting. Let's prove that by putting this in the quadratic equation. So I'm saying it's when x squared minus 4x plus 4, it touches the x-axis once. And when it's minus x squared plus 4x plus 4, it touches the x-axis once. And the reason for this is a perfect square. X minus 2 times x minus 2. And this is a perfect square. X plus 2. X plus 2. Let's see that. It's better to always see it visually. Let's stop that. So according to me, when this is 1 and this is positive 4, the potential answer for having an x-axis that touches once is both 4. There it is, 4. When it's x plus 2, x plus 2. Are the possible roots, and that can only equal to 0 when x is minus 2. And finally, when minus 4. And there's the other one. What happens in between when this one changes? What happens in between when this one changes? So when y is equal to x squared. plus 4x plus 4, we discover. Well, let's do this, but this time we're going to make this k. I'm just going to call it k. We're going to add a slider for k. We're going to make k go from minus 10 to 10. So when it's minus 4, we can see, and I'm just going to turn off these other ones. We can see it's there. And when it's plus 4, we can see it's there. What about when it's 3? Oh, it's a little bit there. 2, there's a little bit there. 1, 0, minus 1, minus 2, minus 3, minus 4, and then finally minus 5. So we can see in between minus 4 and 4, it has, when k is like 5, or sorry, 3. So when it's between minus 4 and 4, the parabola is above the x-axis. And when it's above 4 or below minus 4, it's going to be below. So visually we know what's going to happen. But how do we solve that? We have two possible answers here. Well, let's just bring back everything. The two possible answers so far, that it's going to have two equal roots when k is 4 and when k is minus 4. When is it got no two roots that are not equal, i.e. when the discriminant is bigger than 0? See, it's bigger than 0. Keep in mind our b here is k again, our a is 1, and our c is 4. So we still have this situation. And instead of b, it's k. Minus 16 plus 4 times 3, yeah. 16. A was 1, that was it. So it's 4a squared. So it's b squared minus 4ac. So yeah, it's minus 16. It's equal as, sorry, bigger than 0. So we have to solve. We have to add 16 to both sides. And then we have to take the square root. Well, it's when k is bigger than 4. And here's the weird one. When we do the negative version, you have to change the sign. It's smaller than 4. So we can see that when will we have two real roots? Let's see if that works. When k is bigger than 4, yeah, or smaller than minus 4. Yeah, that's when we'll have two roots. And another way of saying that is by saying, well, no, that is the only way to say it. And what about no real roots? What's the same formula? When is k squared minus 16 smaller than 0? When we add the 16, this. So the answer to that is when it's smaller than 4. And then when we do the negative version, we have to say bigger than minus 4. Well, another way of saying that is when k lies between minus 4 and 4. Like that. And I don't know if it will accept that, as if I can do this like this, minus smaller than 4. Yeah, it won't really show me anything there. Yeah, so I can't really solve it algebraically using that. But visually we can see that that's true. When this is minus 3, it's above, and when it's plus 3, it's above. And that'll be true for any number between minus 4 and 4. Okay, it's hard. It's easier if you practice them more. That's how you solve it. And just keep in mind, when you do this, the negative version, you have to switch the sign. It's kind of like dividing by a negative number. Hopefully that's a good start.